Hello ladies and gentlemen, this is Working as usual. Today I'm going to talk about the measure of relative location. In a previous video record we talked about the measure of central tendencies, and that one is the tools, or it is a statistical tool that we use to summarize a data point by the average value or by one typical values. Now let's talk about the measure of relative locations. As the name indicates, this is about location. This is about position. This is about your point, your places, location. So, in the measure of relative location, let's ask you some basic question. What is the measure of relative location is? What are the indicators that we use to measure relative location? Do you know about percentile, quartile, deciles, or those things? Do you have any idea about those indicators? Percentile. It's related to percentage, isn't it? Quartile. And then we have also deciles. So do you have any idea about these things? How we calculate them? How we make interpretation of them? For what reason we are using them? These are some of the brainstorming questions that you need to ask yourself before you watch these video records or before you read the note in the materials. Now let's go for it. So the measure of relative locations. So from the concept, the measure of relative locations means it helps us to know the place of a given data point relative to the other data sets, relative to the all data point you have. What is the position of that specific data values, data points? It helps us to know the point or the place or the position of a given data values relative to the others, relative to the whole data sets or data points. So this is about position, this is about location, right? This is about locations. So the first one is percentile. Of course, as the name indicates, percentile divides your data sets into 100 equal parts. Percentile divided your data points into 100 equal parts. It's related to percentage for that matter. That's why we call it percentile. So a percentile provides information about how the data are spread over the interval from the smallest values to the largest. As usual, before you calculate percentile, the first task you need to do is that you need to order your data from the smallest to the largest. Ordering the data from the smallest to the largest is the first step you need to in calculating percentile. Percentile it is one of the ways that we make a summary. Of course, this is the way that we understand the data sets. It is a summarization. Still, we are summarizing or we are doing some things to understand the characteristic of your data sets, percentile. So the P's percentile is the value says that at least P% of the observation are less than or equal to this value. When we say 25 percentile, that means if you get 25 percentile, let's say the value for 25 percentile is some data points, then the interpretation is like this. It goes like this. 25% of the data actually less than or equal to that data values. So the P percentile is the value says that at least P% of the observation, at least P% of the observation are less than or equal to these values. 25% of the observations are less than or equal to that data points. We will see them in practice. On the other hand, 100 minus P, because percentile divided the data into 100 parts, 100 minus P% of the observation are greater than or equal to these data values or these data points. Let's see in practice. So calculating the P's percentile has 3 steps. The first step is arrange the data in ascending order from the smallest value to the largest values. That is the first task. The first job you need to do is that you need to order your data, whether you used it, some kind of tools like Excel sheets or maybe spaces or whatever tools that you have. You can use them or you can do it by your hands. If like the number of the data point you have are few, then you can do it by your hands. Otherwise, you need to have some tools that can help you. So the first task is ordering them in ascending order. Ordering them in ascending order. Then computing the i's index. So the index is actually calculated by P over 100 times 1 times the number of the observation. P means, for example, if I say calculate 85 percentile, so in this case P is 85. 85 over 100 times the number of observation you have. P is the percentile of interests. If I ask you to calculate for T's percentile, so P in this context is 40. N is the number of observation. Then to make the final decision, if I is an integer, if I is not an integer, if I is not an integer, if it has some kind of decimal places on it, round up to the next integer. So the next integer greater than I denotes the position of the P's percentile. It is not the P's percentile, it is the position of the P's, it is the location where you can get the P's percentile. It is the position of the P's percentile. It is the location of, it is the place where you can get the P's percentile. If I is an integer, then the P's percentile is the average of the values in a position I and the position I plus 1. So that you need to get the value on I and then you need to get the value on I plus 1 from your data point, add them, divided by them in order to get the mean, and then that is the P's percentile in that context. Let's see them in practice. Arrange the data in ascending order. It's fortunate that the data is already arranged in the ascending order: 3310, 3355, 3350, 3450, 3480, 3480. It's double. 3490, 3520, 3540, 3550, 36. So these numbers we have, this we call it, actually they are beginning salaries, and then we want to calculate 85 percentile or 85th percentile. 85th percentile. That means we want to get a data value on which 85% of the observation are less than or equal to that data point. Now we calculate it in this ways. P is 85, N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, N is 12. Then we got it 10.2. This is not an integer, it has a decimal point. So we need to approximate it. We need to round it to the next integer. The next integer is 11. Therefore, 11 is the positions, it is the place where you can get 85 percentile. Let's count the 11th position. 1, 2, this is the first position, second position, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. 11th is this one. Therefore, 3730 is 85 percentile. The value is 3730. Now the interpretation is like this. 85% of the observation are actually less than or equal to 3,730. 85% of the observation. On the other hand, 100 minus 85 is 15, right? 15. On the other hand, 15% of the observation are actually greater than or equal to this data point, this value, 3,730. 85% of the total observation are less than 3,730. 15 of them are actually greater than that. That is how we make interpretation by using percentile. It's very important, especially for score. You know, grade 8. In grade 8, there are two numbers. There are two grades. When you get in ministry, I think you remember in ministry. In ministry, we have percentage, percentile, and the average. Most of my, for that matter, my percentile was like 99.98. 99.98. Relative to the other community, I am doing very good. I'm like doing the best. So that we use like percentile in order to know what percent of the observation is less than or equal to that data point. It's like, for example, 85% of the observation are actually less than or equal to 3,730. It is amazing. Isn't amazing? Returning to the data, we see that the 85 percentile is the data value with 11th position, which is 3,730. Measure of relative location, and another example, as another illustration of this procedure, let us consider the calculation of 50th percentile for the starting salary data, the previous data. Applying step 2, we obtain that like 50th percentile. So P is 50th, so 50. Number of observation is always 12. Now we got integer 6. If you get integer, you need to get I, which is 66, and I plus 1, which is 7. You need to get the data value on 6 position and on 7 position. The data value on 6 is 3,490. The data value on the 7th position is 3,520. The average is 3,505. Therefore, the 50th percentile for that data set is, of course, 3,550. This is the median for that matter. This is the middle value. Note that the 50th percentile is also the median. The median is the data point or the data value that divide that data set into two equal parts. So 50th percentile means it is the median. It is the middle values. How we make interpretation of this number? We make interpretation like this. 50% of the observation are less than or equal to this. The other 50 are also greater than or equal to this number. It is like that. Now let's talk about another measure of relative location, which we call it quartile. Quartile actually divided the data point or the data set into 4 equal parts. The values that divide a set of data into 4 equal parts are called quartile and are denoted by Q1, quartile 1, Q2, quartile 2, Q3, quartile 3. Then it like this minimum values, quartile 1, of course, arranging your data sets in ascending order is the first task that you need to do. So mean is in this case minimum value, max is the maximum value, Q2 is the median. The same true. Here Q2 is of course 50th percentile. Very simple. Q1 means if you divide your data into 4 equal parts, let's say you have, maybe in picture is very simple. If you divide your data into 4 equal parts, Q1 means 25th percentile, Q2 means 50th percentile, Q3 means it is 75 percentile. Then if you want to calculate Q1, just about calculating 25 percentile. Q2 50th percentile. Q3 75 percentile. So let's see the example. Starting salaries data are again arranged in ascending order. We already identified Q2, which is 50th percentile, 3,505. Now the second quartile, the median, which is 3,505. Now let's go for Q1 and Q3. Q1, the first quartile. The first quartile means 25 percentile. So that we can use the same formula that we use to calculate percentile. In this context, Q1 means 25 percentile. Q1 means 25 percentile, Q2 means 50th percentile, Q3 means, or it corresponds to 75 percentile. Therefore, if someone asks you calculate Q1, one way, of course there are many ways you have to get it. One way is just get 25 percentile. Q2 50th percentile, Q3 75th percentile. So now for Q1, let's go for it. It is 25 over 100. The number of observations are 12. Then we got 3, which is an integer. If I, your index is an integer, you are going to apply rule number 3b. 3b means this one. 3b. If I is an integer, the p's percentile is the average of the value on a position I and I plus 1. So it is 3. I is 3. I plus 1 is 4. 3 means 1, 2, 3, 3,450. 4 means 3,480. So you need to add them. 3,450 plus 3,480 divided by 2, 3,465. Quartile 1 is 3,465. That is as simple as like adding something. But the interpretation is very essential. What does it mean then? That means 25% of your observation are actually less than or equal to this number, 3,465. 25% of them are less than or equal to this number. On the other ways, if 25% of them are less than this number, the other 75% of your observation are of course greater than or equal to 3,465. I hope you can do for quartile 3, Q3. The answer is here. Let's give this as an assignment for you to do it. I hope you can do it. So these are the two measures of relative locations that we can discuss in these courses, but we have also deciles which divided the data sets or the data values into 10 equal parts. Decile number 1, decile number 2. So that decile simply is about dividing your data into 10 equal parts. But getting the value is very simple. Decile 1 means it is 10%. Decile 2 means is about percentile of 20. Decile 3 means is about percentile of 30. Decile 4 means is about percentile of 40. So that calculating percentile for 40 or 40th percentile, 50th percentile, 60th percentile is very simple, isn't it? Once you know this formula, you can 60th percentile, P in this context is 60. 70th percentile means decile 7. 80th percentile means decile 8. It's about decile is simply about dividing your data into 10 equal parts, and calculating decile 1 corresponds to or is equal to getting percentile of the 10th percentile, decile 2 the 20th percentile. So it's about multiplying by 10. If it is 2, multiply by 10, 20. If it is 3, decile 3, multiply by 10, it is 30. It is a percentile, 30th percentile. It's very simple. I hope this is also another assignment that you need to read more about what decile is. It's about dividing your data into 10 equal parts and how you can get the values. It's about getting the 10th percentile, the 20th percentile, the 30th percentile. It go like that. And how you make interpretation. That's all assignment that I give for you. And in the next class, I may ask you such type of question. Be ready to answer it. Thank you very much for watching this video record, and I hope this video record help you to understand how you calculate the measure of relative location. Thank you. In the next video record, I'm going to talk about the measure of dispersion. I hope you understand what the measure of dispersion is. This is an assignment, home assignment. Before you watch this video or the next video, please read about the measure of dispersion from our material, reading material, or search for that, Google for that, and I hope you will have some basic information before watching or before coming to attend the session or the classes on the video as well as the reading material. See you next time. Thank you very much for watching this video, and I hope this video help you to understand what the measure of relative location is. See you next time. Thank you.